after the keynote presentation of AMD's new GPUs, there's always some interviews and all that for media who attended the event, and well, I'm not there. This is a PC World video with an interesting interview, which gives us a whole bunch of information about some of the details that I think people were wondering about, including me in my last video, talking about the reveal event, all of that. So today's video is a whole bunch of follow-up and more details on a lot of the interesting topics. What did the interviewers say? What got talked about that probably shouldn't have been? Anyway, let's jump right in and dig into the details. So in this PC World interview, we get some very interesting quotes. So for one thing, like for example, in my video talking about here, when I was talking about how they didn't talk about how does it compare against the NVIDIA competition? And I speculated at the end of the video that, well, given its price position, the obvious competitor to the 7900 XTX isn't the RTX 4090, it's the RTX 4080. But since the RTX 4080 isn't out yet, then there is no performance numbers for AMD to put it up against, right? They don't have one, at least they probably don't have one. I don't know how corporate espionage works these days. But anyway, they're definitely not officially supposed to have one and put it up against their GPU. So Frank Azor, talking to PC World, has basically confirmed that. So they say the Radeon RX 7900 XTX is designed to go against the 4080. And we don't have benchmark numbers on the 4080, so that's the primary reason why you didn't see any NVIDIA compares. A $999 card is not a 4090 competitor, which costs 60% more. This is a 4080 competitor. So there you have it. It's officially a 4080 competitor. That was pretty obvious by the price, and that does explain why we didn't get the comparisons against the 4090. Now, when they're saying it's a 4080 competitor, we're definitely talking in terms of price. Now, performance will be an interesting comparison there, because are they going to blow it out of the water in rasterized performance for less money? That would be pretty cool. Now, another thing that we had a lot of questions about was FSR 3. And people like me were speculating on whether or not FSR 3 was something that was kind of a last-minute knee-jerk reaction to DLSS 3 frame generation, or whether this was something that had been in the development pipeline for a long time. And luckily, the PC World interview has touched on this topic as well. By the way, I'm using the video cards article here. All my sources will be in the description, but it's, rather than play the video out loud during my video, and I don't know if that would get me a copyright strike or whatever, it's easier kind of to look at the quotes here being reported by video cards. Anyway, but this is from the PC World video as the source. So talking about AMD FSR 3. Now, to be clear here, because this is something people misunderstand about DLSS 3 as well. It's almost like bad, like I get why they're using the names DLSS and FSR for these technologies, but these very much are different than FSR and DLSS in the traditional sense. Those are upscaling. You render the game at a lower resolution, and then it takes some temporal data, things like that, and generates a higher resolution image. DLSS 3 frame generation, and now it's looking like FSR 3, although the details are more limited, don't do that. They're actually not generating new game engine frames from a lower resolution. At least DLSS 3 frame generation, and then by extension, it seems like FSR 3 from what we've seen, are taking 2 frames and making a kind of a fake frame, an AI-generated frame that makes the motion of the game look smoother, but doesn't actually increase the rate at which the game engine is generating new frames and processing data. So it usually has a latency penalty, not usually, it just always has a latency penalty rather than real frames, which, have you decrease your input latency. Anyway, so FSR 3, to be clear, is a, well, I was going to say a reaction to DLSS 3, but I guess he's saying it's not a reaction. It's a competitor to, right? DLSS 3. So let's just do the direct quote. FSR 3 is not a reaction or a quick thing to DLSS 3. It is absolutely something we have been working on for a while. Why is it taking a bit longer for it to come out? that you'd probably hope than you'd probably hope for, I think is what he meant to say here. Well, the key thing to remember about FSR is the FSR philosophy, and FSR until now did not just work on RDNA 2 or RDNA 1. They work on other generations of AMD graphics cards, and they also work on competitors' graphics cards. So hear that. So basically, remember that DLSS is locked to RTX cards, and DLSS 3 frame generation is locked to only NVIDIA's 4000 series cards. And so currently, right now, the only GPU that can use it is the 4090, and the 4080 will get it too. But AMD has always kept FSR open, right? And not just to all AMD GPUs, but competitors as well. So they're saying it's exponentially harder than if we just made it work on RDNA 3. We really do want to work on more than just RDNA 3. So to be clear, he is not saying it does work on other GPUs, but he's saying that they very much want it to, and he's using that as the stated reason. Now, whether that is the true reason or just one of many reasons, the reason that they want to highlight in their PR, who knows? Remember, you are hearing from an AMD spokesperson who has their company's image in mind. We always need to understand that. But the stated reason is that it looks like they're trying to get FSR 3 to work on, as many GPUs as FSR does. Now, NVIDIA's stated reason for why DLSS 3 frame generation cannot work on older generation hardware, even RTX cards from the 3000 series and the 2000 series, is because it relies on optical flow accelerators that are present on those older cards, but not as quick and advanced, and that if they did make DLSS 3 work on those older cards, it wouldn't work very well, and also they just need to put time into making it work there. So, in other words, it looks like AMD wants to support a broad range of hardware here, and that's their excuse for why it's taking longer to come out. This is both exciting and worrying, because I already feel like DLSS 3 frame generation, I have a 4090, I can't. By the way, some people are like, you criticize the price of these $1,000 cards and you buy an RTX 4090. To be clear, I am a GPU reviewer. I bought it to make reviews. If I was just buying a GPU as a high school teacher on that salary, I'd pay maybe $500 max. So let's be clear on that. But anyway, I do have a 4090 for testing purposes. And DLSS 3 image quality can be pretty good. I like it in Plague Tale Requiem. But in Spider-Man with the faster motion and stuff, I have some issues with the image quality. So if AMD has to go to support a broad range of hardware, I wonder if that's going to reduce the image quality that they're able to hit with this. I would love it if they do some sort of magic, and that's not the case. But I do have my worries, because do I want to go off on this side tangent in this video? I think I will. XeSS from Intel has actually convinced me that NVIDIA is not necessarily wrong or greedy to limit the hardware on which their DLSS 3, not just DLSS 3, but DLSS 2 works. In other words, why doesn't it go back and support like the NVIDIA's 10 series cards and things like that? Well, Intel with XeSS has a very similar technology to DLSS 2, not 3, by the way, I'm talking about DLSS 2. But they've designed a fallback that does work on other cards, but the problem is it doesn't work well. And so if somebody who doesn't have an Intel Arc GPU that has the XMX cores to accelerate it tries out XeSS in a game, it's not going to work very well, and it's not going to look all that good. Whereas XeSS on an Intel GPU actually looks and runs very well. It's, I watched the hardware unbox comparison, and it looks almost as good as DLSS and looks a little bit better than FSR2 when it's running on Intel Arc GPUs with the XMX acceleration. But when it's not and doesn't have that acceleration, it's worse than FSR2 significantly in both performance and the image quality you're getting at that performance. So in other words, there is a reason for both quality and for marketing purposes that you would want to keep only the best version running on your GPUs. And that's bad for, supporting a broad range of hardware. But the average consumer might not be educated on, well, the DLSS that runs on this GPU actually looks and runs better than the DLSS that runs on that GPU. So NVIDIA's choice is just to lock it down to only the good version exists, to keep that brand image and that, Anyway, I don't want to get too sidetracked on that. But in other words, I think it's great that AMD wants to support these. And if they're able to do that and have it work really well and look really good, this will be fantastic. But I think that's an exponentially harder challenge than just making it run on, an RTX 4090. You see what I'm saying? All right, let's move on. So Azor continues to say that supporting one architecture is easy, blah, blah, blah. So I think that's pretty much what I was just saying. So in other words, we'll see what happens with this and if they are able to support older hardware and just deliver a good quality competitor at all. Now, this was not the only interview that PC World published, and this one is even more interesting because this guy says that the AMD architecture is designed to go past 3 gigahertz, despite the fact that it's, the boost speeds that they're publicizing aren't going past 2.5. So, very interesting. And he basically, as he says it, says, wait, I don't think I was supposed to say that. Pretend I didn't say that. Okay? So, in other words, there are there's embargoed information being revealed at these events. So there's the public announcement, and then there's behind closed doors embargoed information for reviewers that they can't talk about until those embargoes lift. It sounds like this is heavily making it sound, at least, like this architecture is designed to go past 3 gigahertz despite what we're being told as the game clocks, which is really interesting. Now, this article I'm looking at here is a videocards.com article where they're crediting a source, Mr. Blonde, for the photo. And this photo is an example of the type of thing that might be going on behind closed doors, but is not released to the general public. Again, I cannot confirm if this is real, but it certainly looks real. It has the little end notes at the bottom. Anyway, this seems legitimate. So one thing, hey, here's a block diagram. Kind of interesting if you wanted to see the official AMD block diagram, or I guess I should say, if this is real, it's the official block diagram and all of that. This is showing you guys how even though they have the same number of stream processors, they're on this dual compute unit layout here, so it doubles the amount of floating point operations on each of those. So this is kind of cool to look at. And remember, it's this MCM chiplet design that's allowing AMD, well, one of the things that's allowing them to hit the lower price targets for a variety of reasons, because, if these, if one of these breaks in manufacturing, it's a small piece of die that breaks, right? And then also they can combine the more expensive 5 nanometer process with the cheaper 6 nanometer process. Anyway, it's a really, really cool design. This is one thing in my other video where I was like, did I forget anything? It's late at night, whatever. I meant to talk more about how exciting this design is from a cost and efficiency perspective. It's a really, really cool design, and I'm excited to see where they go with this chiplet idea in the future. But anyway, on here, there is something interesting that was not revealed officially. So officially, we've been told that the Infinity Cache amount is actually, I think, cut down compared to what we'd seen on previous generations, although the speeds might be up, that kind of a thing. But this is talking about the cache system. So we have 96 megabytes second gen Infinity Cache. In this diagram, it breaks it down into L2, L1, and L0, where there's a 3 megabyte L0 cache, which is a 240% increase, and a 3 megabyte L1 cache, which is a 300% increase, and a 6 megabyte L2 cache, which is a 50% increase, and a 96 megabyte second generation Infinity Cache. So it's my understanding that the closer the cache is to the core, right, like that L0 cache, the bigger impact it can have on the overall performance. Now, I'm not a chip designer, so maybe I'm wrong on that. But you know, getting that L0 and L1 cache as a 240% and 300% increase, you know, respectively, seems like a pretty big deal. Now on here, I didn't see anything else that looked particularly like new information. However, am I blind or something? Because in this video cards article, they say the slide also mentions that the RDNA 3 architecture is to exceed 3 gigahertz, which they're saying might confirm reports like the one I'm talking about here. But guys, am I blind? I'll link this in my description. Tell me if I'm just blind. I tried to read every little line here. I mean, there's some stuff along the edges that's hard to read, so maybe I'm just missing that, but I don't think so. Anyway, I don't see it. I'm not seeing it. I don't know if I'm blind, whatever, but the article is saying that the slide mentions the RDNA 3 architecture to exceed 3 gigahertz. I don't know. Did they get another slide that they didn't publish here? Can I scroll left or right? Are there more pictures? I don't see anything. Anyway, now when this 3 gigahertz information started coming out, people wanted to follow up on, wait, does that mean that like the AIB partner cards are going to have insane overclocks, things like that? Well, it looks like Cortex on Twitter is saying that some people asked during the stream, so I asked AIBs, and they are saying about only a 3% OC over the XTX with preliminary drivers that have been used mostly for thermal testing, to be fair. If true, then it looks like the XTX is already close to maxed out. So, according to the AIB partners that Cortex was able to speak to, it's looking like only a 3% OC compared to the XTX, which certainly would not be pushing you from a 2.5 gigahertz to 3 gigahertz. So does that mean that AMD's really sandbagging their gigahertz claim, and maybe the XTX model actually goes way past 2.5 when you're actually using it, but they're just listing 2.5 as the guaranteed clock speed on the box? And then you can go 3% past that, or maybe the 3 gigahertz thing isn't real, or it's for a different GPU that we'll see in the future. I don't know, guys. So interesting stuff, but let's move on to other topics. So speaking of the actual cooler design and all that, so Gamers Nexus, right? We've got, you know, good old hardware Jesus talking about the actual card design, and he noticed a really cool sensor here. It seems like there is a temperature sensor, what is that called? A thermistor, kind of hidden on the fan. And this could be useful, first of all, to make sure the card is aware that even if the core is cool enough, are there other parts nearby that are too hot? This sensor could come in handy for that, which he mentions in his video. And then in a follow-up community post, he talks about, we posted that new video about the thermal sensor in the fan for the 7900 XTX and how cool it is. How cool. Anyway, sorry. I feel like that's a pun, maybe not intended. Anyway, was just talking with someone else who pointed out the thermal sensor for ambient temperature on the 7900 XTX is also super useful for tech support and CS teams, since it'd help rapidly confirm a hot case as a cause of high GPU temperatures. Anyway, so this is cool. I don't think this is some kind of mind-blowing, amazing feature or anything like that, but it is cool. Like, it's nice to have that sensor. I think they asked about whether it would be exposed to users, and they said possibly with official software. However, the company has not made any official comments on the matter. And so it's also not clear if board partners will be adding similar sensors to their designs. In fact, no brand except ASUS have shown their 7900 series yet. And with that in mind, how about we talk about the ASUS cards? So in other words, we've seen the reference design. What about the AIB partners? Well, ASUS has showed off their TUF model, and it will ship with a dual BIOS switch. And it's a triple slot design with full metal backplate. There's a picture of it. And hey guys, you know what I'm mostly noticing is it looks a lot like my, so this is the 6800 XT. This is the ASUS TUF model. I'm trying to get it in the camera and look to see if it's in frame. But would you guys agree that, can I tilt it at the same angle? I mean, it doesn't look like a particularly updated design, right? Like, that doesn't mean there aren't some changes or internal changes to the cooling or anything like that. But I saw this picture and I was like, that looks like my 6800 XT. But actually, guys, I think that's part of the point of these this AMD GPU. Part of the cool thing here is that they don't need to make some ridiculously oversized change or adjustment to their coolers like they had to do moving to a 4090 Ti. No, sorry, the Ti model's not here. But with the 4090, we saw a lot of these absolutely massively redesigned coolers that are just huge, right? And the new power connector and all of that. So this seems to be showing that the TUF model, at least from what I can see, is, well, you know, about the same thing as what I've already got on the 6800 XT, and that's not a bad thing, right? If that can save everybody money, the AIB, you know, designers could save money, you know, all that kind of stuff. Now, these are being listed with over 12,000 cores, and this brings up just a bit of a side note. Remember how I showed, where was it, this slide, right? And whether this is official and real or not, anyway, it's the idea of these dual compute units per stream processor, or you know, per shader engine, or however you want to talk about that. I mix up the vocabulary, but the point is, you know, officially, we're at, you know, the 6,000 number, whatever the exact thing was. Yeah, officially we're at 6,144 stream processors, but since they're doubling the compute that can happen on each stream processor, sometimes these are getting listed as 12,288. And I really hope AMD chimes in and gives us an official, like, can we have a standardized way of talking about this? Because right now it's a little bit confusing with exactly how we're supposed to be talking about that. Anyway, in addition to, I mean, this is not really an AIB card, but in cooler designs, we are already seeing an EK water block. So if you're interested in water cooling this, EK is talking about this. They're ready with their EK quantum vector water blocks for the reference model designs. And looks pretty cool. And let's see, what else did I want to get into? Oh yeah, last thing I want to talk about was a follow-up again to my previous video. That's not the page. That was the page I was on. Here we go. So follow-up to my previous video here. So I talked about the performance, right? We looked at the baseline performance slides of the RTX 4090. I looked at a meta review to establish the 6950 XT's average performance of the 4090's performance in both rasterized performance as well as ray tracing 4K performance. We got some numbers, we looked at some percentages, and used that to talk about how it would compare against the 4090. Now, I want to do a few more percentages here because I saw some people talking in the comment section, that kind of a thing. And so let's end on a little more talk about these percentages. So basically, if the 6950 XT is 57.1% of the performance of the 4090, that means you would need to get 1.75 times the performance of the 6950 XT to match the rasterized performance of the 4090. I did that in the video, but then what I probably should have followed up on then is then, okay, if the actual number, so AMD claims up to 1.7 times the performance. So now if we look at it this way, 1.7 times the performance compared to the 1.75 is 97% of the performance. But the 1.7 is an up to. That's not an average. That's like a best case scenario. So if we called that like 1.6, that would get us to around 91% of the performance in rasterization of the 4090. And if in some of the games we're only showing a 1.5 uplift, and a 1.5 gets you to about an 86% performance of the RTX 4090. So those are your scales. It looks like it'll be anywhere from 86 to 97% of the performance of the RTX 4090. But again, this is napkin math. This is not official reviews. This number is, you know, based on a meta-analysis average of a lot of reviews, and the 1.7 and the 1.5 and all that is just numbers off of an AMD slide, so we'll see. But we'll be somewhere in there. Now, if you look at that in terms of, I'm going to call it 1.6. Now, if you look at that in terms of the prices, it's $1,000 compared to $1,600, and that's assuming you could get an MSRP RTX 4090. So that's 62.5% of the price for 90-ish% of the performance in rasterization. However, I find this really interesting. If we look at the ray tracing numbers, again, according to that meta-analysis, the 6950 XT was 37.8% of the performance of the RTX 4090 in 4K ray tracing. And that gives you a 2.65 times advantage for the 4090. But then if we take AMD's slides and take it as maybe a 1.6 uplift in ray tracing performance, given the slides that they gave you, and then look at that as a percentage of that 2.65 uplift, right? They're getting, 60% of the way there, right? So what's interesting then is how that then compares to the pricing. So it almost looks like their price compared to the 4090 actually scales well to its ray tracing performance compared to the 4090. Now, AMD on slides like this one, even say they could have up to 1.8 times the ray tracing performance at 2.5 gigahertz. So they could have up to 1.8. So if it was 1.8, that would be getting, 68% of the ray tracing performance of the 4090, for 62.5% of the price. But if in reality it was more like a 1.5 uplift, then we'd be at like 56% of the, anyway, this is all napkin math, but I thought these were some interesting percentages to look at when you look at its price to the 4090. But again, like we said, the 4090 isn't really the competitor. It's the 4080. And so I think it'll stack up a lot better against that. Now, let's go ahead and end this video. I hope all of you have an excellent day.